Hey everyone, in today's video I will be demonstrating my heatmap assignment for the CS6250 course. For this project I am using the AftrBurner engine along with modification inside the OUNPPM source code to extract a 2D heatmap slice from a 3D volumetric and animating data. Let's jump right into how the heatmap system works. So the main idea behind this project is generating 2D cross sections from a 3D volume, and each slice represents the radiation magnitude at a specific position, and I can visualize slices along x, y, and z axis. The first step is choosing which scenario I want to visualize. To select the scenario, I can use the drop down here from scenario, and I can select scenario 0, ideal localizer, ideal glide slope, or any other kind of scenarios. Once I select the scenario, I can browse for the specific dat file I want to load by browsing from the dat file. If I didn't pick a custom file, the system automatically falls back to the default dataset. So if I didn't select any file, it will fall back to ideal localizer.dat file. After selecting the file, the workflow is pretty simple. First, I need to click on init to initialize the scenario, and then click on generate output button, and then parse output to load all the radiation data into the engine. Once I click on the parse output, then to visualize the heat map, I can use the show heat map slice checkbox. If I click on the checkbox, it will generate the heat map. As we can see on the screen, the heat map is generated. I have used the HSV value from blue to red, and the heat map with blue color represents the lowest magnitude and red color represents the highest magnitude. And once the heat map is generated, I can select the plane that I want to show the heat map for. If I click on the slice axis drop down, it will allow to choose the plane x plane, y plane, or z plane. And there is another slider for slice index. It will generate the slice for the different index. Index is determined by the step size and the maximum bounding size of the data 3D volume. And for this case, there is a step size of 100 and total of 3000 by 3000 grid. So slice is generated at 100 feet distance, and the total number of slices in here is the 30. Like we can see, if I change the slice, you can see that the intensity, the heat map of that slice is being changed. As I increase more, the heat map will change accordingly. And I have added the generate catch button, which will create catch for all the heat map slices. And if I click on the animate button, the heat map will be animated along that axis. Like if I want to animate the visualization for along G plane, I can just click on the animate single axis button, and we can see that it is being animated. Let me go up, and stop animate button will stop the animation. If I wanted to change the plane, let's see, for the X plane, you can see that visualization is frame change. If I click animate button, it will animate along X plane. And for the Y plane, the ideal localizer data looks Heatmap for ideal localizer looks like this. And let me try with another scenario ideal glide slope. If I press init, generate output, and then parse output, it will start generating the radiation data from heatmap compatible. If I click on the show heatmap, you can see that the heatmap is generated along y plane. And if I click on generate charts and then animate single axis, you can see the heat map at different slices for the ideal glide slope scenario. And if I change the X plane, the heat map will be like this. And along G plane, the heat map will look like this. And I have two other buttons. So bounding box, it will display the bounding box of total width, length, and height. And if I click hide bounding box, it will have the hide the bounding box. That's all for my heatmap assignment. Thank you for watching.